No idea. Yes, I call other was with the news changing basically KAMO.
Yes, I know. So changing happens with all. It's easy.
Like ultimate choice between T cells. Yeah, that's what I figured. That's what I figured out. They took that as one out of it. This gets a lot of energy.
I'm just pulling up my Jupyter. Get that set up. Okay, so at least if everything's on schedule, homework 2 is done, it's turned in, and now today taking a look at project number 2. If things are different, especially in midterm season, that's okay. Just keep us updated, put a note in the Husky CT submission, and yeah, let us know what's your new like submission date. Oh yeah, and I heard somebody talking about like, hey, there's MD, because when I built this, I must have forgotten to put this .md into this link. So if you try to click it, it tells you that it's not found, but we know how to find it. We're just going to add a .md right at the end. And right in that hyperlink, now you're into that project. And anytime you're in this, like anywhere in your Jupyter Hub, like NanoHub, Jupyter Hub, you can always click open. And it'll bring you into like a folder structure of the class. So there's module 1 through 5, and then the projects would be like module 2 project 3, 4, 5. All right, so we're going to take a little bit of our data processing analysis, a little bit of Monte Carlo predictions, combine those into like some kind of predictive model here for like New York Stock Exchange data. So I'm going to look at Google, and then you can choose any stock price you want, try to repeat the analysis, and then the key is like, usually what people struggle with is quantifying what that model actually did. Like, is it good? Is it bad? Accurate? Is it precise? Like, these are and if you say that it's accurate, how accurate is it? So accuracy is always some measure of error. Like a small error means very accurate. Precision means very small, like usually some kind of standard deviation, or if you had like a box plot, there's no outliers in your predictions, something like that. And this like random walk hypothesis, this is how, I mean, they like in general, there's a differential equation that you can solve, but Monte Carlo methods can solve differential equations. So we're roughly creating like a same kind of solution that would be used for shorting stocks, like same kind of thing. Like if you wanted to know how much a stock price is worth if you were going to short it, then this is the kind of analysis that you would use, like some kind of random walk. There's some bias, like it's either you think it's going to increase by a certain amount or decrease by a certain amount, and then this is what you would, this is the general kind of process for derivatives of how that gets calculated. Usually they solve like the differential equation, so they have exact functions, but you can do it this way too. So we're going to load in some stock exchange data. I think this one goes up to, let's see, 2016. So right, New Year's Eve 2016. And when I'm looking at this, I'm going to split it into two different data sets. One is everything before this drop in 2014. Everything else is like the rest of the data. And I'm just doing that to show one of the things that can't be like if you don't include big drops in data, then your prediction is not going to have big drops as part of the Monte Carlo model. Like, so I'm specifically excluding that just to show what can go wrong. Like, all right, I have all this data, it's predicting that it's always going to go up. And like, yes, that's true if we're always interpolating, but as we extrapolate, if there's something weird happening, then we have to be a little careful. I think this big drop was actually like the company split, like Google split from Google to Alphabet. Like there were two things happening. So if you knew that, you could probably split the stocks, put them both down, and then do the same analysis. But so the stock price has like some kind of function that it's going up, it has a lot of variation in it. But if I look at just the change in the stock price, it seems random. And the reason that I'm saying that is like the chance of it being 0 seems just as likely as it being like 60. It just seems like something is happening, or maybe not uniformly random, but there's some kind of mean, and then there's some kind of like lots of noise to it. So in this kind of noisy signal like that, I could say, all right, there's something statistical happening, something like maybe not random. It depends on your philosophy about if randomness is possible, but maybe it's random, maybe it's chaotic, but something like where I need statistics to describe it. In general, first best guess for random variables is a normal distribution, a whole bunch of random factors that I don't know what they are. As I add them all up, it turns into something normal. Normal distribution, not normal occurrences. So it looks like average price change was 0, and standard deviation is probably like $10. And in fact, it's like 57 cents and 9.84, which is pretty large. That's a really large standard deviation. It's very hard to even see what that average price change was. We know that it had to be more than 0 though, because we went from 600 to 800. So over, I mean, that was 7 years. Here, even, we went from 600 to 1200. So we doubled the price in 4 years. So there had to be growth. The average growth has to be something, even with all those like chaotic changes. I was saying random, but we're going to use pseudo random. So if I have normal distribution, I can create like Monte Carlo, normal distributed random D price, like changes in price, delta price. And then sum those up and say, as it catches up with me, there we go. And here I did a little bit of work so that I could have, the only data that I used was 2010 to 2014. And as I get to 2014, my average prediction, so all those like rainbow colored walks, those are all like random walks that could have happened based on the data that I have as it changes in price. So there were chances that it could have been going down. Some of them were going up. Like this would have been like really good couple of years all the way at the top. This could have been like a really bad couple of years. But overall, like the average change in 4 years is exactly what the average change was, which makes sense because I used that data to find what the average change was. As I keep extrapolating further into the future though, now I start getting bigger and bigger errors because I didn't factor into account, I didn't take into account the fact that the company split. So really I should have like after 2014, like the day that it split, I should subtract some and then increase it. But now I've got some numbers that I can say, here it's accurate, precise, like inaccurate. So along here, I'm always within like one to 1.5 standard deviations of the actual stock price, at least for like mean and standard deviation, mean and like mean and error in the models. But then as I get out here, I get into like, I'm predicting 1500, but the actual price is 2 full standard deviations below that, down at like 600 or 700. All right, that was just like a walkthrough. I know you could have read that, or maybe you already read that, but I thought it might help to take a little intro step as we're all loading things in. How's it going so far? Any hiccups? Yeah.
Well, the data seems different. It looks like that at least what's published running through the whole thing with the pre-2014 data.
Yeah. So I had changed mine to keep going. Price model. I'm trying to find where I actually create that price model because I extended mine so it would keep going. So right in here, when I say D-price model, just making this a couple of lines. Depending on how many dates I want to use, if I want to use like the full, if I want to create data for the entire data set that I have, so I can look at training and testing data. So here, training would be like how much data I use to create a mean and a standard deviation, and then testing is the stuff where I continue making predictions and I can directly look at the stuff that was not included in that mean and standard deviation. So this location and that scale are based on just that first graph that I made, that D price, the change in price before 2014. And then this Google data is the entire data set there. Yeah, if I change this to pre-2014, doesn't really change like what the model predictions are. Like it's still going to look like a normal distribution. But when I plot this, oh my god, pre-2014 and the price model, now I'm only making predictions up until 2014, right before that they drop. Let me check in, see where people are at. Yeah.
Just go through some more your couple just detailed questions on this. So starting with when you did your X value for your thin space, minus 44.
Yeah.
So why did you choose those values? Because I can see it's roughly kind of like changes are roughly between 40 and 40. Is that all it was?
Yeah, and also I knew the standard deviation was 10. So if I get 4 standard deviations, then the tails are going to be pretty small.
Okay. So then I got an Amazon. So if my standard deviation is about 7. Okay. Same thing would be over. I did 40 to 40.
Yeah.
As well, so that's about the same.
Yeah.
I guess it would be 7, so about 30 to 30 maybe.
Yeah.
It wouldn't really make a difference though.
It doesn't look like a huge difference.
No, I kept changing it. I didn't notice any difference really.
And that one is just showing you like that X is just the actual like Y wall.
Yep.
That normal distribution. Wow.
Okay. That was number 1. Number 2, when you did your default RNG, why did you plug in 42?
The only reason is that it creates the same price model for everyone.
It's the same seed function basically?
Yeah.
Okay.
Same seed.
So you could plug in any number there. You just have to
Yeah.
42. It didn't matter that it was 42.
Yeah. And
Okay.
if you plug in nothing, then it just
It'll make a difference.
makes a difference.
Okay. Now, when you're doing cumulative sum here, using the axis, so you did axis equals 0 sum by column. Yes, it's axis 0 sum along the columns.
Yeah, yeah.
And then axis 1 must be sum along the rows.
Yeah, so row. Yeah. Yeah, so then every column was
A new model.
well, it was like every day had a change in price. So I wanted to look at for one model, what was the sum of all the changes in price. And the cumulative sum, it's almost like an integral.
Yeah.
Yes. It gives you like
And then when you wanted to sum by row, that's when you were taking the average and the standard deviation, because you were saying for each day, basically what was the standard deviation between all the cumulative sums. Okay.
Yeah, because then you could do like the mean, or sorry, like the sum of all rows across the road and then divide by number of rows.
Okay. And then lastly, when you're doing error bars, what does the Z order mean?
So I think this is actually just a law mentions to like not like good, but they got rid of the
order.
yeah where it is they used to be higher than salary but then they got rid of
Like so it's
that's the other side.
now I can't remember for error bars.
Just floating.
I'm trying to remember. I know there was a reason for it.
I changed the number and it changed the graph significantly. Like
Yeah.
it would disappear all of a sudden.
Yeah. So Z order, the bigger the number, the closer it gets to the top.
Oh, the top of what?
Like if you think of it as like organizing visual like pictures.
Like layering basically.
Yeah.
So if you had
The top layer.
Zero is going to be the furthest down.
Yeah, everything is going to be over top of it.
Okay, so this is Z order 3, meaning of all the things that are showing up on the graph, it's going to show up on top of them because there's only 2 other things basically.
Mm-hmm.
So if we increase the Z order, it should remain the same.
Yeah.
Because
it should be the same if you increase. Yeah.
Yeah, and then if you drop it to 2 even. Yeah, it goes away. Or it's hidden.
Okay.
That makes sense. Okay.
I might do one.
So it's just a labeling thing on the graph.
Yeah, that one.
Yeah, you can see because you set the alpha to 0.3. You put the Z order to less than that. You can see it behind it.
Yeah, if I put it as like 2.
Yeah, you can see the dots, but you can't really see the lines as well.
Yeah, because that one's changing like where the error bars are. If I change it to 2, because I think all those rainbow plots are in order 2.
Yeah, they are.
Versus, if I say 10, then it's just going to be above.
It won't change it.
It should be the same as what it was before.
So it's kind of a different way to do transparency, sort of.
But it's not transparent. Like it's still,
You want to show it.
Yeah. It's creating like your own layering sort of thing. Yeah. Yeah, and this was, we were just, if you're joining, trying to figure out what we're doing, just debugging, or not debugging, but digging into Z order. I can change what layer the plot is. And I think it'll work in almost every, I think there's always an argument for Z order in every matplotlib.
So.
Yeah.
Yeah, so thank you. Yeah.
flavor if you want.
Yes. Now, if you want to make sure the link works, you can this without process. I just left it off. So it works in our like we need website here and some stuff doesn't know where that file is.
What is probably the
It isn't the so now the way it operates, so location is the mean. Compare that to the way the and then scale is what information.
This is crazy. We need to decide.
Oh, I guess you were
This is just how many books there are. This is my brace. This one was tough. I'm gonna do that one. I didn't know about the cat either.
something that it was numbers I got from
I'm not gonna have my cap and gown. I'm just gonna have this in the
This is in the outside party on the inside.
All right, jumping back in for question that came up online. So I'll come down to like the deliverables of where it's telling you next steps, choose your own stock, explore the data, find some stat descriptions. So you can go through the exact same analysis. Like you can take the code from above, apply it in the same way. It's up to you how you want to do that. Like if you're taking like Apple stock here, NVIDIA is kind of cool to see because that one you see like nobody cares about graphics cards, and then like everyone cares about graphics cards, and their stock price takes off. But you can take a look at those if you want to try. Like I think some great ways to use this kind of analysis is splitting it so that you have some data that is used for predicting and some data that is used for testing your prediction, which is what I did up above, just splitting it out, that 2014 data for Google. And so that's like, you can take that same analysis and apply it, and that's totally fine. That's a great way to start. And then you should really be answering these questions as well, of like, what are the caveats to this method? So at least in my case for Google, when the company splits, my model does not take into account the fact that people can split a company. It just says like, things are good, things are going to keep increasing. So that's a caveat. If I continued predicting prices, I have an exact price in 2015 and even like 2016. I have exact prices that I can compare to exact prices. You could even look up like on Yahoo stocks, you could take it and predict it all the way to 2024 and say, what's the difference between my prediction and 2024 like actual data. So those are great ways to like answer these questions of also like how accurate and how precise this model is. Sorry, another question?
So there's no way to like do the drops in this model and it not screw up the prediction?
No, we could. Like if here the this drop was a very big announcement. Like people knew this drop was coming. And I think what I could do is say, let's see. So price model. what I want to do is come up to date, because I just want to take it and subtract that amount that I already knew was coming. So what do I do? So I'm trying to just take that at this date, subtract like 600 or something. I think I can do that. Pretty sure. Oh wait, that's a I want to do the D price. So if I knew the price was going to drop by 600 on 2014 3/2, then I could set that of like, hey, this is the change in price on that day. Let's see what that does. Not much. Doesn't seem to make a huge difference, right? But there should be a way. I'm pretty sure I can like shift everything down by 600 on that day. I'll have to think about it, because there is a way that you can say like at this time drop it down. Oh, so the question came up, can we use some TensorFlow or PyTorch? You are welcome. You are always welcome to try like some new stuff. So let's see what TensorFlow could give us. Because you could, TensorFlow has a nice like train and test if you want to split it up day by day. But what would we want to do? Keras. So really, we would want some kind of like model optimization, I think, or like a structured data. We don't want to, so we're not trying to, at least if you want to use like TensorFlow or PyTorch, you're not trying to classify data. So that's one thing that we're not trying to do. We're trying to create like, for a given input of a date, give us a price. So if you want to do something like that, go for it. Yeah, sounds awesome. Reinforcement learning. I feel like it would be something. Pet finder. No, see, this is all categorical. We don't want categorical. We want like actual numerical vision. So let's look at PyTorch. Maybe they have. Tensors. A neural network should be able to give you the same sort of things. But a lot of times neural networks are used for classifications. Model layers, neural network. I mean, you might be able to do this. I think it would be like model optimization. Multi-objective, first principles. Yeah, if you want to try something more advanced, you're welcome to. I'm just trying to find I'll have to look into that more. Maybe that'll be my afternoon project. Because a neural network in general should be able to create any function you want as you keep tuning hyperparameters to it. So it should be able to it should, like a neural network sooner or later could create this black line. For every date, it'll give you exactly what the price was on that date. It might not be too helpful for extrapolating, but it will give you that same thing. Or you could use a neural network to get a better, right now we're just using pretty simple normal distribution to describe these changes in price. And some of these changes in price are not really normal distributions. So if you wanted to get a better set of Monte Carlo random numbers, maybe you would want, like here I've got really kind of like an extra little tiny normal distribution down here, like as if there's like one big one around 57 cents and then another small one around negative $22 or something. But anyway, yeah, if you want to try, you're always welcome to build some bigger things in there.
Yeah.
Also, it's P1, right? See, and how long your people P1s for? Just yeah, exactly.
Yeah. At least you
It could be less, but it's better than nothing.
I got 3 weeks. You don't get more until you work at the but you know, you buy it.
Yeah, it's not a little too. And then when I run the rest, okay, yeah.
Yeah, way closer to like what the action is.
I was wondering why it was like so.
Yeah. That would be something like in the caveats, like, well, this never worked even from day one. Like, as soon as it was more than one day, it was always off. But now it's the mean is always within, and here, like, that's really accurate, right?
This is one standard deviation from
Yeah, exactly. Yeah, it's not very precise. Like you can see that the models keep spreading out and that together, but it is very accurate. Okay. Yeah, that big drop. When, I don't know what happened to eBay. That would show, yeah, you just. Oh, and then use that same. Okay. Here. Another week done.
Thanks, Brandon.